Hey, how's it going, everyone? Justin again, as always. Thanks for watching my channel. Welcome back. We are midway through the week. How about that? All right, today is going to be more of like a case study. It's on a 2000 Dodge Dakota with a 4.7. The engine was replaced about 2 years back. The vehicle runs very poorly and barely holds an idle. That's the complaint. Upon visual inspection, the radio interference wire, if you guys know what that looks like, it's a braided wire that goes usually to the back of the head, was disconnected and was just kind of flopping around. And there were two engine grounds, at least I believe they were two engine ground sensors that were not only not connected, but there was no harness connector for them leading to them. The trouble codes that were found was a P0305, so cylinder number 5 misfire, a P0205, injector 5 fires inappropriately, P0206, injector 6 fires inappropriately, P0112, intake air temp sensor voltage low, and a P0123, TPS voltage high. Now, you have to pick a path when you're getting ready to diagnose, and cheers to those of you that have your beers, if I haven't said it already. But you got to pick a path to determine what direction you want to go in, because at this rate, with this many codes, there could be multiple issues, or there could be one issue causing multiple codes. So I decided to pick a path. To start with, I decided to go after the TPS. So, choosing the TPS. So let's take a look. So TPS position, I'm checking it out. Here are the codes. As I told you, we have about 5 or 6 codes available. You have to pick a direction. So the direction I chose was to go after the throttle position sensor first. At wide open throttle or closed throttle, you want to see if the percentage changes from 0 to 100%, which it seemed to do so as I was depressing the gas pedal. The TPS data voltage showed us anywhere from just about 0.6 of a volt up to about 3.7 to 3.8 volts. The TPS signal voltage again being at 0.6, which would explain why we were getting about 0.6 volts on our signal wire when we used a back pin probe and a DVLM to check it out. So if we're going by, let me just pause this for a second. If we're going by the 90-10 rule, we should be close to about 4.5 volts signal voltage at wide open throttle, which would explain why when it's closed we have 0.6 volts instead of it going down to 0. So that might make up the additional difference of why we're off. Now, is the difference caused because of a lack of cleaning? It's just so dirty that it's not fully closing, which is causing that? Or is it a bad potentiometer within the throttle body itself that's causing it to not close all the way, because there's a coil wrapped sensor inside, and as the throttle plate moves up and down and closes and opens, it determines how much throttle position is actually open or closed, which then sends volts, etc., ground, whatever. So the next thing we got to look at is, what does our ground tell us? Alright, so now we've established that wide open throttle goes up to 3.9 volts. It matches the data voltage that we got on our scan tool. We let it go, falls back down to 0.6 volts. Now we're going to check ground voltage. So with the wire back pin probe connected to the throttle position sensor, we're checking ground voltage. We're at 10.3 millivolts with it closed. Now going open, nothing changes. All the way closed, nothing changes. Looking at the wiring diagram will help us to determine a lot of different things. So looking at the wiring diagram, we have a supply voltage of 5 volts coming from the PCM straight to the throttle position sensor. We have a ground voltage going straight from the throttle position sensor to the PCM. And then we have a signal wire that connects with the TCM going straight to the PCM. So at this point, we need to see if we have 5 volts available at the throttle position sensor, which we do. So now what's our next path? Here's the potentiometer. You can see a squiggly line straight on down to ground. So now we have an issue. Do we condemn the throttle position sensor itself. Do we condemn the throttle body because Identifix says that the most common repair practice is to change out the throttle body? Or do we go and do a resistance test or ohm the circuit from the PCM to the throttle body itself? That's the next question. So TPS ground closed voltage, which we'll just go kind of recap, 10.3 millivolts. That seems a little bit high. Now we know that there are a couple of ground straps that are not attached to the engine, which might be part of the issue, or we could have a failed driver in the PCM for the ground side. Looking at the wiring diagram, our TPS 5 volt supply voltage is 5.22 volts. That was with the DVOM connected. And the code that we had showed that the throttle position sensor voltage was too high. But looking at the actual data and the DVOM voltage itself, so the power supply that we had was 5.22. Our signal voltage was 3.9. It doesn't quite equate. The missing voltage, I think, is in the ground. Now, I'm not a professional diagnostician. I don't pretend to be, but I'm very interested in learning, and now that I have the ability for this car to continue to learn, I'm trying to see and snuff out the problem, try to figure out what the problem is. So I'm checking it out. Okay, so we checked that stuff out. I've got an idea of what it is we have to tackle next. Either we have to volt drop or do an ohm or resistant check between the computer connector C1 to the throttle position sensor to make sure that we don't have any kind of a break in a wire or a short to power or something got melted. And we have to check the ground side. Once we conclude whether or not the PCM has a sufficient ground or that the wiring in between is good, that will determine whether or not we have a bad driver or we have a bad throttle body or throttle position sensor. We have to figure those things out. So that's what's on the to-do list. I'm still looking into this. Okay, looking at the Misfire codes. So if we look at the Misfire codes, let me pull it back up real quick. Alright, so looking at the Misfire codes, so we had the P0305, P0205, P0206. So two injector codes, one Misfire code that could point to a bad coil or a bad plug or something like that. First instinct is to use a Noid light, see if we have any flashy flash going on at the fuel injector. We do. So, and why did I go with the smoke test? Because we had not only misfires in 5, 6, 7, and 8 as far as the counters were concerned, but most of the codes that we had as far as the P0305, 205, and 206, it was kind of interesting, so I would suspect an intake leak at that point. I want to make sure you plug everything off. Like, this thing had a torn PCV boot. I plugged everything off, including that PCV boot bypass, plugged all that off. No leak, except for in a couple of areas which didn't really pertain to the codes that I was getting, so we kind of ignored it. Next thing you can do is pull a plug, see where you're at. So we pulled a plug. I found out using the bench that I had on the bench vise that I have in my toolbox, that we were at about 58 thousandths gap, 57 thousandths gap. Found out the spec was actually 40 thousandths gap. The electrode was a little bit worn. The plugs were a little bit old, but at least they were champions. Could that be the issue? I'm not sure. So what I did, I bent it down to about 40 thousandths, which is what the spec was. Put the plug back in, rechecked Misfire monitors to see what was going on, and still all the Misfire monitors are going off. I pretty much ran out of time after that. I didn't have any more time to continue on to figure out what the next step was. Now, I don't know if I'm actually going to be allowed to come back to this case study tomorrow or throughout the week. I hope that I'm able to come back to it because I'm still curious as to what's going on. Is it a bad PCM? Is it a bad throttle body? Is it bad injectors? What is going on? But just to kind of give you an idea of how the kind of mindset that you have to have when you're trying to diag a vehicle, especially one that has multiple codes. One, pick a direction. Two, once you pick a direction, don't assume that every code that you have all ties into the same exact thing. Now in this case, it might. It might just be a really bad PCM that is affecting everything. However, we could have multiple issues. Now, the engine was replaced a couple years back with a reman engine. The throttle body looks like it hasn't been cleaned in years. The fuel injectors looks like they were transferred over from the original engine. And same thing with coils, same thing with plugs. The plugs look old as hell. It doesn't look like they replaced them. If they were replaced within 2 years, we wouldn't see the kind of gap that we had, which means that the customer probably wanted to cheap out a little bit and did not want to replace the plugs during the time that the engine was actually swapped. This happens. Now we have multiple codes, and now we have multiple decisions to make. Which thing do we tackle first? Which item is more crucial? How do we separate good from bad? I mean, you got to start somewhere. Most places will say, let's throw some plugs at it. Let's swap coils, see if that changes anything. Let's throw a throttle body at it. Let's throw an idle air control temp sensor at it. Let's see if that fixes it. If it doesn't, then we'll go towards the PCM because that's the most expensive part to replace. No, don't do that. Try to do your research. Try to go online. Look, I pulled up this wiring diagram. I started fishing around trying to come up with ideas, different things that we could potentially test. I have other test methods that I haven't done yet to this vehicle to see if I can condemn one part or the other. We still have the injector drop test, a power balance test. I still have to disconnect the idle air control valve to see if it changes voltage at all when it's connected or disconnected. There's a handful of testing still left to do in order to condemn one, two, or multiple parts. So you guys let me know. Have you ran into an issue like this? If you haven't, don't worry about it. I'm still learning this stuff as I go. I'm just glad that I was given the opportunity to actually try to dig down a little bit deeper and try to figure out the issue. I'm glad I could actually share it with you too. But I'm really excited about trying to dig into it a little bit more. Now, hopefully there's a part 2. Hopefully I'm able to reconvene and come back at it and see what the heck we got going on. But if I don't, it is what it is. This is as far as I got. But at least you guys can see some of the process and how it can take a very long time to diagnose a vehicle. That's all I got for this video. Thanks as always for watching. Cheers to those of you that have your beers. I hope you're enjoying your work week. We'll see you again next time. Deuces.